Hey guys, happy Wednesday. Today we're going to be talking about more lines. This time we're writing equations of lines. So all week we've started talking about this form called slope-intercept form. We've talked about slope, we've talked about intercepts, and now we're kind of moving into you writing equations of lines. So again, slope-intercept form is in the form of y equals mx plus b. And m again is our what? Slope, and this b is our y-intercept. And we can always tell what our m, where our slope is, because he's always right next to the x. That's how we can tell. So if I have this equation down here, it asks me to find the slope and the y-intercept. Well, it's given this in this form, y equals mx plus b, right? So I can just look at it and know. That's why it's called slope-intercept form, because I can look at it and it gives me a slope and it gives me the y-intercept where it crosses the y-axis. So the slope is the guy next to the x, which would be the 2 in this case. My slope is 2, and my b, or my y-intercept, is positive 1, right? And if I were to turn this into a point, it would be 0, 1, because I'm going over 0 on my x and I'm going up 1 on my y. Now, slope is always rise over run. So what's a way I could turn 2 into a fraction for rise over run? Keeping it 2, but making it into a fraction. What about 2 over 1? 2 divided by 1 would simplify to 2. So anytime you have whole numbers and you're trying to find slope and do rise over run, if you put it over 1, it will make it into a fraction. And this is why I was so adamant about making you turn everything into fractions and not decimals, because with slope, it's rise over run. And if you've got some sort of decimal, you will have no idea what the rise and what the run is. You have to have that fraction. So now we're going to graph it. So looking at this, I'm always going to start with B. That's the beginning. Beginning. That's our starting point. So in this scenario, my beginning, my y-intercept was 1, or 0, 1. So that's what I'm always going to do first. So I'm going to start at the beginning, and I'm going to put over 0, up 1, and put a point. That's step number first, doing that. From there, from the beginning, I'm going to go to my slope and go rise over run. So it's a positive 2 and a positive 1. So what I'm going to do is go up 2, there's my positive 2, and then go over 1. There's my positive 1. Remember, going to the right is positive, because if I think of a number line, all my positive numbers are on the right, all my negative numbers are on the left. So I'm going positive, so it's the right, and then I'm going to put my point. And if I do it again, I always say 3 points makes a line. So if you give me 3 points, I'm happy. I'm going to rise 1, 2. There's some positive 2 over positive 1, put a point. You can also do the opposite. So like I went positive, positive. You can also do negative, negative. Because if I had negative 2 divided by negative 1, what would happen if I simplified that? I would have positive 2 over 1. Because a negative divided by a negative is a positive. So I could also go down to 1, 2, down negative 2, over negative 1, and put a point, and that would work. And then all you're going to do is connect the points of these points. And there's my line. So again, you start with B, the beginning, and then you're going to go to your slope and do rise over run. If they're both positive, you can go up and to the right. If they're both, you can then change it and make them both negative and go down and to the left. Those would be the same exact thing and make your line the same. So let's look at number next. This one again is written in slope-intercept form. It's written in the form y equals mx plus b. So first it's asking for slope, so I'm looking for the number next to my x. What's my coefficient next to x? There's no number, but there's a negative. So how many x's do you see? 1, but it's negative, so it's a negative 1. Then I look at my y-intercept. That's the guy all by himself for B, by himself. -2. And again, if I turned that into a point, it would be over 0, down, -2. So I'm going to go to my graph, and I always start at the beginning. I'm starting with B, my y-intercept. I go down -2 and put my first point. Every single time, start with your y-intercept. So your first point should always be on this y-axis, on this line right here. Then we're going to look at our slope. It's not in a rise over run. I need it as a fraction. So again, how did I say I could turn my whole numbers into fractions? By putting 1 underneath it. So I'm going to take this -1 and just put a 1 underneath it. So I'm going to look here at my point, and I've got a -1. So this time, instead of going up, what's happening? I'm going down that -1, and then I'm going over to the right 1. That's a bad way to put it. Let me move that over. Down -1, and then over to the right, +1, putting a point. Down -1, over +1, putting a point. You can also do the opposite, because this whole fraction is negative, so I could also make it to where I've got a +1 and a -1, because that would mean I would go up +1 and to the left -1 and put a point. You can do the opposite as well, as long as the whole thing's negative. So just like we did this positive one, if they're both positive, I can change them both to be negative. Over here, if one's positive, I can change it to be negative and the other one to be positive, as long as the whole thing stays negative. If there is one negative sign in there, it's going to make the whole thing negative. Then I'm just going to connect my points, and there's my line. And you can always check yourself. I always say draw your dump, your slope to dump. So puff, puff, positive, nice, negative. This is 0, fun, and undefined. So you can look and know, hey, my slope here had to be negative, and negative goes this way. Is my line going that way? Yep, sure is. I did it right. So you can always double check and say, hey, my line's going this way, and it really should have gone the other way. I did something wrong. Same thing here. This line, it needs to be positive because I have a positive slope. Well, is this going up the puff, puff, positive? Yep, it's going up puff, puff, positive. So we're good to go. Y'all, that's all there is to graphing. Start at the beginning, your B, put your point, and then you're rising over run. Rise over run. Give me 3 points, and that's it. Says, if you can graph a line given an equation, that also means you can find an equation, give it a graph, right? So if I give you the equation, you can graph me a line. But what if I give you the graph? So what you're going to do again is start at your beginning. Where's this line crossing my y-axis? Well, here's my y, and it's crossing right here at -2. So my y-intercept is -2. So that's my B. I need to find my slope. So what did I say to find slope on a line? Get 2 what? 2 pretty points. Well, y'all, I already have one for my y-intercept. I just have to find another one. And the one that stands out to me is this one. There's a couple more on here that you could use. That's just the one that stands out to me. If we all use different points, we would all get the same slope because it's going at a constant rate. That is what makes a line. The constant rate, a constant increase or constant decrease. As soon as it speeds up or slows down, that's when the curve hits. So then I start at my bottom point, and I go up until I meet the line. So I only had to go up 1, but then I'm going to the left 2, so that's a -2. So my rise over run would be 1 over -2. So now I've got my slope and my y-intercept. I just need to put it in the form y equals mx plus b. So the y equals and the x all stays the same. Now I'm looking at my slope, which was -1/2. So filling that in for m. And then I'm looking for my plus b. In this case, it's a -2. So I'm going to put minus 2. There's the equation of my line. Let's try number next. Again, I'm going to start at the beginning, the y-intercept, so looking where it crosses the y-axis, which is right here at 0. So my y-intercept, let's just put b. My b is 0. Then, to find the slope, 2 pretty points. I already have 1. This is the next one that stands out to me. You could have picked a different one. I have to go up positive 2 and over to the left, negative 1. So the rise over run is up to negative 1, which simplifies to negative 2. So again, if I write it in y equals mx plus b, I have y equals, the m is negative 2, that's right here, and the b is 0. So I could put plus 0, but does that really change anything? Oh, there's the x, sorry. Does the 0 change anything? No. So usually we do not include the plus 0. I won't count off if you put the plus 0, but on tests and things, you will not see a plus 0. So there's nothing there that automatically means it's going through this origin. It's a 0. It's automatically 0. I don't have to put plus 0. So that would be your equation to the graph. Let's try this next one. Okay, so again, find the y-intercept, your b. Well, that's right here at 1. Then I find another pretty point. This is the one that sticks out to me. And then I'm going to start counting upward. 1, 2, 3. So positive 3, and then over to the right, 2. So my slope is rise 3, run 2. So it's y equals 3 over 2 x plus 1 would be the equation. Or you can find an equation given a slope and a y-intercept. So I'm given my m and my b, so this is actually less work. All I have to do is fill in where everything goes, right? So m is negative 3. Everywhere I see an m, I'm putting in negative 3. B is 5. Everywhere I see b, I'm putting 5. So let's just fill it in now. Y equals negative 3x plus 5. That easy. 6, same thing. Y equals mx plus b. M is 4/3 this time. So we're here at m, I'm putting 4/3. And b is negative 2. Everywhere I see a b, I'm putting negative 2. So y equals 4 over 3x minus 2. This next one, y equals mx plus b. This one looks a little different. My m is still the same. M equals 1/4. So we're saying m, I'm putting 1/4. Now my b, this is giving me a point. 0, negative 8. But hey, aren't y-intercepts written in 0, comma y? So whatever is here should be my y. So that is my b. So I've got y equals 1/4 x minus 8. How are we feeling? Those aren't too bad. If it gives you an m and a b, you're good to go. Or if it gives you a point, 0, negative 8, that's your y-intercept because I'm going over 0. I'm staying on that y-intercept and going down 8. Okay, let's look at the back. So we've been given on the front, we were given an equation and we could find the slope, y-intercept, and graph it. We were given a graph and we could find the slope and y-intercept and write the equation. We were given an m and a b and we could write the slope-intercept equation for it. Or you can find an equation given a point and a y-intercept. But first, you must find the slope. First, you must find the slope. Well, what do I need to find slope? I need two what? Miss Miller calls them pretty points. I need two pretty points. If I look at number 9, I only have one pretty point, and then I've got this b, -2. Can't I turn that b, -2 into a point? What is that saying? That's saying I'm going over 0, down, -2, and putting a point. So that point is 0, -2. Can't that be my other pretty point? So now I have 2 points. We can do the equation, or we can use Desmos, which is what I'm going to do. So in Desmos, I'm going to hit this plus button and hit the table. Now here's where my x's goes. Here's where my y's goes. My first x is -6 and my first y is 1. So I'm typing -6 and the y for that one is 1. My next pretty point is 0, -2. So come back here. So I'm going 0 for the x, -2 for the y. Then I come down here and I type in y1, shift squiggle, mx1 plus b. Then I look down here and I'm given my slope and my y-intercept. Slope and y-intercept, which is -0.5, which I want as a fraction, which you know. If you just type in m and then hit the fancy fraction button, it'll do it for you, which I think is pretty cool. So you don't even have to type in the -0.5. You can just type in the m and it'll do it for you. So our equation is, I'm given an m, which is -1/2, and I'm given a b, which is -2. Well, now I can write an equation, right? Because if I'm given m equals -1/2 and b equals 2, can't I just do it like what I was doing up here? Yeah, right? I can just write it as the equation. So if I'm writing it as y equals mx plus b, I'm putting -1/2 everywhere I see an m, and I'm putting a 2 everywhere I see a b. So I've got y equals -1/2 x plus 2. So super easy. Use Desmos and then plug in your m and your b and you're good to go. Numbered x. This time I'm given 2 pretty points. What is this point? That's my what? My y-intercept, or my beginning. That's my b right there. But I'm given the 2 pretty points. So I'm just going to go to Desmos. Let's get rid of all this. Again, plus table. Put in my first point, which was -3, 4. Second point was 0, 8. Come down below, and I'm typing in y1, squiggly, mx1 plus b. I'm given my m and my b. Again, we don't like decimals because that has nothing to do with us for rise over run. I could never tell the slope of 1.33. I have no idea what that is. So I'm going to come down here, type in m, and press the fancy fraction button, and it tells me it's 4/3. So I'm given my m is 4/3 and my b is 8. So if I come back over here, I'm given m is 4/3, b is 8. So if I go to fill this in into my slope-intercept form, y equals mx plus b, well, everywhere I see an m in the equation, I'm plugging in 4/3. Everywhere I see a b in the equation, I'm plugging in 8. So I should have y equals 4/3 x plus 8. Not bad. And number 11 is the exact same way. It's given a table. You do not need to plug in the whole table into Desmos. Remember I say you only need 2 pretty points. So I usually just pick the very first 2 pretty points. It does not matter what 2 pretty points you grab. I do not care. But I usually just grab the first 2 because they're right there and they're pretty handy. So I'm just going to look at these first 2 pretty points. So let's go to Desmos. I'm going to hit this plus sign, table, plug in my first x, which is -4. My first y is 8. Then 0 and 2. Come down here, y1, squiggly, mx1 plus b. I look down here. Here's my m, here's my b. This is given as a decimal. That's a no-go. Type in m, hit the fancy fraction button, and I'm given -3/2. So my m is -3/2. My b is 2. Gives it all to me right there. Whoop, come back. So if I'm given, and whoop, writing with highlighter, m equals -3/2 and b equals 2, I'm filling it in to y equals mx plus b. Everywhere I see an m, I'm plugging in -3/2. Everywhere I see a b, I'm plugging in 2. So I should have y equals -3/2x plus 2. Okay, let's look at some of these word problems because I think this is where we get kind of messed up on. The first one says, John began with $75. B is our beginning. Began with. That's the key word there. Began with. That's our B. Began. In his savings account and deposited $20 per month. Per means to multiply, so that's 20x. And remember, whatever's next to my x is my m. Looky there. I've got an m and a b. Can't I write an equation now? If I were to write an equation, I would have y equals m is 20x plus 75. There's my equation. It's asking me, how much money does he have after 2 years? So if I've got this equation, y equals 20x plus 75, well, x is how many months? Well, this says 2 years, so I need to change 2 years to be months. So that's 2 times, how many months are in a year? 12, right? So that should be 24. So I'm going to plug in 24 everywhere I see an x. 20 times 24 plus 75. So that way it will tell me how much we have after the 24 months or 2 years. So I'm going to multiply 20 times 24. So I get y equals 480 plus 75. Then we add those two together and I should get 555. So after 2 years, he should have $555 in his bank account. If we look at the next one, it's asking if he wants to purchase a new laptop that costs $800, how long must he save? So this time we're looking at the money. So we want to know the amount he should save. So instead of plugging in for the amount of time, I need to plug in for the money. So I'm plugging in for y. So I should have 800 equals 20x plus 75. So this time I'm solving for x. I'm going to draw my line down the middle, x, subtract 75, subtract 75. So I'm left with 20x equals 725. And then I divide everything by 20. And you should end up with x equals 36.25. 36.25. And if we think of a real life scenario, you could say 36 and a quarter month. But if I were rounding to the number of months, I would want to round to 37, because if I round down to 36, I'm not going to have enough money. So if I were trying to round to an even number, it would have to be 37. So I know rounding rules are the 5 or more, raise the score, 4 or less, let it rest. But in real life situations, like, you can't have half a person. So in real life situations, you kind of have to think through that. But I'm fine with you leaving it 36.25. So 36.25 months. Okay, 2 more, y'all. We've got Riley began with. That's our beginning. That's our B. Baseball cards, and gave 10 to each, means to multiply. So there's our slope. There's our M. So if I were to write an equation right now, I've got Y equals. Now he's giving 10 away. So am I adding 10 each time or subtracting? Subtracting. So she minus 10x, negative 10x, plus he began with 300. And he gave 10 to each of his friends until he had 100 left. How many cards did he have left after he gave them to 7 friends? Well, the friends would be our x. So I'm going to take my equation, and everywhere I see an x, I'm going to plug in 7. So I've got Y equals to negative 10 times 7, negative 70, plus 300, which would be 230. So you have 230 baseball cards left after he gave 7 to 7 friends, 10 to each friend, right? Then it's asking for the domain of this situation and the range of this situation. So domain of this situation is talking about what? We've got cards and we've got friends, right? So domain is my x values. My x values are talking about the friends, right? I could give cards away to 0 friends, or I could give cards away to 30 friends. It doesn't matter. That's your domain. That's your independent variable. Your range is your number of cards, right? Because your range is your dependent variable, and it depends on how many friends we give it away to. So that's the domain, and that's the range. And then this last one says Ashley's car cost $12,000. So she's starting at a balance of $12,000. That's our B. But then she's making monthly payments of $300. Monthly payments, so $300 per month. Per means to multiply. That's our M. So our equation is Y equals. Now she's paying that $300, so it's coming off the $12,000. So we're subtracting. We're not adding on $300 each month. We're taking off that from her, how much money she owes. But we started with $12,000. So that would be the equation. It said, how much did she owe after 3 years? Well, we've been talking about months, so I need to change this into months. So 3 times, again, there's 12 months in a year, so 36. So I need to plug in Y equals negative 300. Instead of X, I'm going to have 36 months, right? Plus 12,000. Oops. There we go. So Y equals negative 10,800 plus 12,000, which is 1,200. So after 36 months, that's all she owes. That's all she has left. Then it says, at what point was her balance on the car 6,000? So this time we want to know the cost, which is the Y value. So I'm plugging in 6,000 for Y and solving for X. Sorry, y'all, trying to squeeze that in. So minus 12,000. So I have negative 6,000 equals negative 300x. I divide by negative 300, divide by negative 300. That goes away. I'm left with x. I can take some of these zeros away. Negative 60 divided by negative 3 is positive 20. So her balance of $6,000 will happen after 20 months. Then it asks for the domain and range of the situation. Your domain is your x value. It's independent. That would be your monthly payments, right? Monthly payments. Your range, your dependent or your dependent variable depends on the monthly payment. So that would be your balance that you have left, right? Balance that you have left. Okay, that's the notes for today on graphing the lines. And if I'm given an M and a B, I can graph my line. Please work on the Google Form homework. Let me know if you have any questions. Y'all have a great rest of your day. Bye, y'all.